Okay, so here we go. So I'm going to just talk about introductory sensory. So I'll be able to identify the people in the audience who have done sensory by the number of heads that fall asleep, but I think it's a really mixed crowd, so I've tried to keep it at a fairly low level, and we'll go through. Because sensory is interesting. It seems really simple, and it's really tricky to do it right. At least that's what I say, so that you'll come take our course. Okay, so just outline-wise, talk a bit about the definition of sensory evaluation, a bit about bias, a bit about sort of the requirements for sensory testing, and a snippet of a few sensory tests that you may see and that companies can use. So, the other thing I'm in trouble for is that normally I talk for 50 minutes. It doesn't matter how much information I have. I can cram it into 50 minutes or expand out to 50 minutes, and I've only got 30 minutes. And there's no exam for you later. So I actually have to keep you entertained. If you're not entertained, just look at the wall and imagine paint drying, and I'll let you know when it's all over. So anyway, sensory really is a discipline to measure and interpret our reactions to foods. And it is really quite interesting because our present state really influences what we taste. It's kind of what Nate was getting at in the bar. There's more to the liquid you taste. Obviously your surroundings matter. Your time of day, your health, whether you've just had a meal, all of those things will influence how you perceive a beverage. Gin. And people are very variable. I used to work with a Polish fellow in a brewery, and he'd talk about throwing valves, and it's very variable, he said, in a really thick accent. It took me a couple days to figure out what he was saying. The valve timing was tricky for him and very variable. And certainly that's the biggest problem we have in evaluating results from taste panels, is the variability of our speakers. Okay, so a little experiment. I'm a scientist after all. We have to have an experiment. So pick a letter. Don't tell anybody. Everybody got their letter picked? I hope you have. It's not that tricky. Okay, how many picked A? Hands up. 1, 2, 3, 4, 5, 6, 7. How many picked C? Oh, geez. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. How many picked B? Oh, God, you guys aren't behaving properly. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's a slight majority for B. I can tell you, if you do this with teenage Canadian students, so you may be relieved that you're not a teenage Canadian student group, they all pick B. 80% of them pick B. And typically that's what happens. What this says is there's a few outliers in the crowd. And if we label our samples ABC, and we ask people to tell a difference or a preference, and they're all very similar, then they're going to pick B. Honest, trust me on this. It really is true in general. And so when you're coding your samples, we typically use a 3-number digit code, randomly generated. So 5, 6, 7, 9, 2, 3, 1, 8. 2318, that's a 4-digit number, just in case it's a trick question. But we code the samples with some random 3-digit code to avoid that bias. It's called a bias of central tendency. This may sound a bit like a applied psychology lecture, and you're right. Sensory is applied psychology. So when we set up taste panels, we can ideally, we want to try, if we're actually tasting, to try and set up a kind of controlled environment. It's not easy to do in many plants, but there are ways to do it. Typically you can get a quiet room where you can close the door and not have the noise of the bottling hall or the still running. And you bring your people in. Ideally, you have taste panel booths. So when somebody comes in, they sit down and there's a divider between them and the next person tasting. And they'll have a ballot form. Because surprisingly, on taste panels, people cheat. People want to get they really want to please and they want to get the right answer, and they'll go, "What'd you get? What'd you get?" And you put the booths up. If they're students, we fail them if they talk, so I don't know what we'd do with this crowd. But anyway, we do try and isolate and get sort of an independent view and selection. We keep it quiet, there's no talking, etc. Sort of common sense things. Obviously no smoking or cosmetics. If you really are doing this sensory-wise quite analytically, like they might do at Camden BRI, for example, or at Heriot-Watt, you have a positive pressure into the room, so you're taking the odor of any of your samples away. You have odor-neutral materials, etc., etc. Uniform lighting. If you're concerned with the color of your beverage and you're not something you don't want to measure, then you can mask the glass with tinfoil or colored glass or whatever. And you can actually use colored lights. I haven't always tasted beverages. In the past, in another life, I actually tasted farm salmon, which wasn't a bad gig actually, but we were concerned with the texture, and we were comparing it, farm salmon from this one farm to another one that had a different diet. And so we were concerned with the difference in color that was showing up. So we put red lights on to bleach the color out so it wasn't influencing, because all those things will influence your results. There's a set of standards for how you design a taste panel room, table height, etc., etc. And there's actually three kinds of tests. There's two written on the slides here, so we'll go through those first. The first one's called discrimination tests, and you probably run into these, I would think. The most common is the triangle test. You give 3 samples, 3 glasses, 2 of them are the same, 1 of them's different. They're coded with that 3-digit code as gain, and you ask them to pick the odd sample. The good news is it wasn't gin makers who designed this test, it was Carlsberg, but the brewers lead in this kind of sensory thing, and beverages really drive it. So this is called a triangle test, and you need a number of results. You need typically 12 to 20 tests, so 12 to 20 panelists who can pick out the odd sample or not. But if you have 20 tests, you basically have to see how many were correct out of those 20, for example, and see whether that's statistically valid and statistically important. Because some of it could be fluke. After all, with the triangle test, if you give people 3 choices and only one's correct, then a third of the panel is going to guess it right. So you've got to use some statistics. It sounds like a very dirty word, and it can be, but basically you look it up at the table. It's fairly straightforward. And then you can say that there is a significant difference. Typically we say 1 out of 20 chance of it being wrong. It's the kind of thing you hear in polls, but basically then you can tell differences. So for instance, if you had 2 gins, let's say you're trying to match your gin to the leader, and so you've gone away and developed yours, and you want to see if actually the public can tell the difference between yours and the market leader, or whether it's exactly the same, or at least not much different. Then you get them to do a triangle test, and you can get the results out of that, and you can use it to guide your product development. Discrimination tests, typically you don't want to train, you can train your panelists. You can have expert panelists doing triangles, for example. And sometimes a lot of effort is put into training the panelists on various flavors and aromas in the gin. The other side to discrimination tests is something called preference tests, and that's where you're asking the general public how much they like. So when you do a triangle, the person who picks the odd sample and gets it right, it may not be the sample they like. It's just the sample, they can just discern the odd sample. With preference tests, you want the general public to tell you how much they like. And in general, if you're getting the public in to taste, you don't want to have them have any training background, because then they're not the general public anymore. All of a sudden their training is influencing the results, and that's not what you'd get in the bar. With preference testing, you can get a random pool. You never want to train them too much. You don't want experts, and typically it's a much larger panel. It's 50 to 100. It's a lot of work to organize a true preference tasting. You've got to be careful if you do preference testing with a university student population. then all you can say is that the university student population prefers the highest alcohol drink you can give them. But anyway, that's another story. You also have to make sure that you're motivating your panelists. If you're doing this over and over, give them as much information about the test you're doing, publicize the results, and if you're doing this in a company you need management on side, you can reward them with vouchers to a movie or something if they're doing a lot of work for you. And typically, you want them to be at least an hour past their meal. I've found in brewing work that 11 o'clock is usually the time when the panelist is most accurate. The panel is most accurate in general. It's probably because they're hungry for lunch. They're not tired yet. They say you should wait 20 minutes after smoking. This is a bit of a dated advice because less and less people smoke, and there's some argument over whether smoking actually decreases your sensitivity or not. Morning seems to be best though. People are a little peaked at 11, they're hungry, so they taste more sensitively. Okay? So again, I said 3-digit code. If you're running the test, you have to be quite careful to be neutral and not talk or give any hints away about the odd sample or the one that they like if you're doing a preference test. And you've got to have the glasses exactly the same. If you give them 2 glasses the same and one different, they're going to be biased to pick the odd sample. It's just common sense, really. Temperature is important. Lighting, all of that is important. Randomizing the odd sample number, so it's not always the one in the center of the triangle. It could be the ones on the side and the bottom, et cetera, et cetera. And there are different types of different testing aside from the triangle test. I mention it because it's most common, but you can actually give them one sample odd out of 6. It becomes more accurate. Or you can do 2 pairs. You can give them a reference sample and ask them to identify the reference sample and the other 2 unknowns. There's lots of variation on the theme. The problem with food testing in general is that we become fatigued. Our taste buds get saturated with whatever odors or taste they're picking up, and you become less and less accurate, and you lose that. And with alcohol, it's even harder because people are usually ingesting alcohol. Tell me it's harder. I've done these panels at universities, and you're always worried about the students consuming the whole sample. It wouldn't be so genteel as it was today where people are taking a small portion out of those cups. If there were university students here, the cups would be all empty by the time they went back up. Okay. So anyway, those are sort of forced choice. We force people to make a decision. There's no, you have to make a decision. And we use them in quality assurance because you can find differences. If there's some batch-to-batch variation you're concerned about, you can see whether that's just your imagination or actually true. And you can also use it in product development. Okay, so we talked about this triangle test. It's about a 1/3 chance to be correct just in random, just randomly. So you have to get depending on the number of samples the number of scores you got back, number of triangles you've run, you can consult, and you need a certain number of correct to say that it's a significant probability of 0.05. You can also rank samples. If you get your panelists a little more trained, or do preference, you can ask which sample do you prefer. That was asked, I think, in the sample that went around. It's simple to administer. It is a disadvantage in that you have to use a bit of statistics, but it's fairly easy to analyze that. Excel can do it, for example. Of course, Excel can do just about everything nowadays. I'm just showing these because there's lots of different tests, and I won't go into the reasons why you would use them or why not, but you can get people to rank the magnitude of an intensity. You can ask them to assign a magnitude to these letters and then use those to rank the intensity. Usually it's a log scale, but it can go on like that. There's some fairly tricky sensory that's done to measure threshold flavors. So if you want to talk about the minimum juniper amount, it's tricky because juniper probably varies from season, well, I'm sure it does vary from season to season, but if you want to ask how much juniper has to be in the gin before you detect it, you can do that. It just takes a lot of work, a lot of triangles actually. And there are different types of thresholds. There's a threshold level where you can tell something's different, something's been added to the gin. There's another threshold where you can say, that's juniper that's been added, or coriander, whatever spice you're talking about. And you can go through those testings. It's fairly academic actually. It takes a lot of work to do, and you can go through those, and they do exist. I don't think there's a lot in the gin literature about that. Matthew's shaking his head. Matthew's Polly is, some of you may know, he's just joined us back at Heriot-Watt. We trained him 8 years, sent him out to learn everything there was about gin, and brought him back. So anyway, he's saying yes, there's not a lot in the literature. There is a bit of psychophysics. I can go on. Sounds kind of like a David Byrne song, but there are relationships between the amount of a compound, its concentration on the bottom, and the perception of it on the left-hand axis, the vertical axis. So this is for a couple sugars, well, 4 sugars, but as you add more and more, you don't always get double the sensitivity to it. There's also a really detailed set of sensory that can be done to measure product characteristics. And it was pioneered actually by A.D. Little in the States some years ago for a lot of different foods. But basically, you go through a lot of training with your panelists. It takes months. And you ask them, for instance, for certain gins, you train them to agree on different attributes of the gin. So everybody's on the same page, because sometimes somebody will say, I don't know, the gin is got a spice note to it, when really it's a burn. And you have to have all your panelists on the same, working from the same set of definitions, and you have to train them to do that. And then you need to get them to try and at least be in the same range when they assign intensity. And you really do have to do a lot of training of your judges and your panelists. When you do that, you can start to get profiles for your different gins. So this one's a student of ours from A Land Before Time, 2003, but they were working on characterizing gin. So you can see there's juniper, fruity, floral, citrus, etc., etc. And she's had panelists go through and plot the intensity of those different characteristics in the gin, and then there's been two different samples, and you get the solid and the dashed line. So you can portray the characteristics of your gin visually, so that people can work on that. So that took a fair amount of time to develop, but that work has been done. It was done by SWRI some years ago. SWRI is the Scotch Whisky Research Institute up on the Heriot-Watt campus. And so one of our students, actually, we worked closely with them, and one of our students did this work and was just trying to portray the difference between two different types of gin. But this kind of graph is used in a lot of different food categories. There's also a flavor wheel to name the different characteristics of gin. This is the result of a lot of work, probably with the panel, probably 3 or 4 months work minimum. And so in the inside wheel, it's just the basic flavors, so citrus, spicy, sweet, floral, etc., etc. And then as you go out farther, it gets more complex and more descriptive. So when you go from green, kind of a plant-like aroma, you can go up to herbal, grassy, leafy, or piney, for example. So it's just a way of characterizing all these flavors in your gin. And it takes it seems quite simple when you put this wheel up, but I know it was a lot of work to do. So that's the kind of thing that exists out there in the sensory world when you're talking about gins in the research side. And it would be, I think, useful. This may be for one certain type of gin, but these flavor wheels have started to come out for different types of whiskey, for beer, for wine, right? Both, different kinds of wine as well. So that sort of thing exists out there, just so you know. The results you get out of sensory are as good or bad as the time you put into it. And it's also, the other takeaway perhaps is that sensory tests are difficult to extrapolate. If you have your staff tasting a gin and say there's a new gin and saying this is the best thing since sliced bread, there's a lot of, for starters, you won't have a lot of panelists. It may be that the owner of the company or the director tasted first and said, I like this. Usually when that happens, the new person just after them goes, I like it too. So you have to be careful about that bias because they get influenced. And not only that, what a trained gin taster likes may not be what the general public likes. So it's just something to keep in mind. Okay, a lot of this is written down. Actually, it's not filmed, so. But my email address is there. We'd be glad to answer any questions you have down the road, especially if you don't ask them today, so I don't look like a fool if you're not answering them. But a lot of this does exist in the literature. I'm waiting for the chip. This is an old article, but I've been waiting for the USB port. You can just plug in, grab the gin USB, plug it in, and then be able to answer all the questions. So thanks very much to the Gin Guild, to Nicholas Cook and Chris Heyman. Chris sits on our advisory board and keeps us in touch with the real world because we are in an ivory tower. Although there's not that much money up in Heriot-Watt for ivory towers. And the Gin Guild, the company of distillers, and for Francis Jack's assistance in preparing this talk. Thank you very much.